So let's look at some examples here. A used car dealer says the mean price of used cars sold in the last 12 months is at least $21,000. You suspect the claim is incorrect and find a random sample of 14 used cars sold in the last 12 months has a mean price of $19,189 and a standard deviation of $229.50. Is there enough evidence to reject the dealer's claim at alpha equals 0.05? Assume the population is normally distributed. Okay, so let's start gathering some information and then see why we're doing what we're going to do. All right, so the used car dealer claims that mu is at least 21,000, greater than or equal to 21,000. And that's the claim. All right. What do we have? Sample size of 14. Sample mean of 19,189. And now realize, because this standard deviation was referring to the sample, that's S, 2950. And then we were given our alpha of 0.05. Okay, so because the population is normally distributed, so that allows us to use one of the two tests, and because we know S, we're going to be using the t-test. So let's go through that. All right, verification. We were told the sample was random. We did say that sigma was unknown. And we did have the population normally distributed, so we're allowed to proceed. All of this says we're going to use the t-test. All right, so H naught, H sub A. Okay, so we went back and we said what we had was that mu was greater than or equal to 21,000 as the claim. Well, that has the equals in it, so mu greater than or equal 21,000, that is the claim. And the rest of that would be mu less than 21,000. And again, if we look at H sub A, that should tell us what tail test we're doing. Since it's a mu less than, that would be a left tail. Okay, significance level was 0.05, degrees of freedom n minus 1, and was 14, so 14 minus 1 is 13. Okay, so now we're ready to calculate t. So again, t is x bar minus mu over s over radical n. So that would be 19,189 minus 21,000 over 2950 over square root of 14, which is about negative 2.297. And like we said before, that would be over here, and we're talking left tail. All right. So when I'm going to get my p-value now, I'm going to go ahead and into Excel, I'm going to put t.dist. Well, not dot, because I'm going to do the default left tail. I'm going to put negative 2.297, 13, and true. And that's how we're going to find it. So let's bring up Excel. So equals t dot dist. All right, I put in the negative 2.297. I put in the 13 degrees of freedom. True. And I get 0.019. 019. And now I can take that, that's my 0.019. I compare that to 0.05 because this is my P and this is my alpha. And I see that my P is indeed less than my alpha. That means I reject H naught. Okay, now I go for my interpretation. Okay, so this was claim here in the null. So we're in a rejection mode. And so what did I find? I found that we were able to reject H naught, which was the claim. So there is enough evidence at 5% significance to reject the claim that the mean price was at least 21,000. Okay, so we were able to reject the claim in this part, in this example. So let's do another. Industrial company claims the mean pH of the water in nearby river is 6.8. Mu equals 6.8. Randomly select 39 water samples, and it's 39. pH. The sample mean and standard deviation are 6.7, and that's S because it's coming from the sample, 0.35. Alpha is 0.05. And away we go. All right. It did say we had a random sample. Sigma was definitely unknown. And we weren't told about the distribution, but we do have a sample size of 39, which is greater than or equal to 30. So we are in line for a t-test here. The hypotheses, the null hypothesis and the alternative hypothesis. Again, this claim here was that mu was equal to 6.8. So that's got to be the null. And mu not equal to 6.8 is the alternative. And when you have equals not equals, that has to be a two-tail. All right, the significance level alpha 0.05, the degrees of freedom 39 minus 1 or 38. So let's go ahead and calculate t. Remember that's x bar minus mu over s over the square root of n. So that's going to be 6.7 minus 6.8 over 0.35 over the square root of 39. And that's approximately negative 1.784. We already knew that we were doing the two-tailed distribution here. So now we're going to go and find the p-value. So now when you're doing, so we're going to do t.dist dot 2t. Now here's where I want to make a point. So when you're doing the two-tail, even though we got the negative t value, so the one over here, we're going to use the positive one. So the formula asks us to do 1.784 and then the 38 there. So this is saying the positive t in this case. So let's bring up Excel and do that. Equals t dot dist dot 2t and then 1.784 38, and we get 0.082. So P is Whoops, I wanted to go back to blue on that. 0.082. Okay, and now we're going to compare it. That 0.082 gets compared to the 0.05 p and alpha. This time the p is greater than alpha, and that means we fail to reject H naught. Okay, and so what were we doing in this one? Remember, we had our claim in H naught in our null hypothesis. So again, we're in the rejection mode. There is, now in this case, we failed to reject H naught, which was our claim. There is not enough evidence at 5% significance to reject the claim. And that does it.